When you have 8 CPU in a machine, in a single CPU, if you execute them, all the 7 remaining CPUs are going to be idle. So hope you remember, or else this is a formula, just memorize it right now. So the point here is, to get the final answer, we actually need to calculate a square first, b square and 2ab. Then we have to add all three. But when you actually see, there is no order, there is no particular order in calculating a square or b square or 2ab. We can even calculate 2ab first and a square second and b square third, right? Or we can actually calculate them in parallel. So this is why we need multi-threading. In programming scenarios, in the real world execution scenarios, there are situations where we can do operations in parallel. So here, when you have 8 CPU in a machine, why you are going to run these three instructions, a square, b square and 2ab, in a single CPU. If you execute them, all the 7 remaining CPUs are going to be idle, and this one CPU is going to execute 3 instructions. It is going to take times to execute 3 instructions. But instead, if you put each instruction like a square to CPU 1, b square to CPU 2 and c square to CPU 3, then all 3 are going to take execute in parallel, and every CPU is going to take just the time of executing one instructions. So by the time, let's say it is taking 1 second to execute one instruction, instead of you waiting 3 seconds, you get all 3 answers in 1 second itself. So it is a 3 times improvement of the performance, right? That's why we are going for multi-threading. So using multi-threading, we can actually do some independent operations in parallel, and it is going to heavily increase our performance, and we are going to utilize the hardware much better.